Hi folks, today we'll be talking about distributions in more detail. Remember last class we talked about histograms, which are the kinds of graphs that we use to display the data for a continuous variable, things like height, for example, and we refer to the overall shape of the histogram as the distribution. Today we're going to talk a little bit more about different kinds of distributions and different variables that might result in different kinds of distributions. Before we do that, I want to quickly recap some of the most important points from the last week's videos in terms of our first venture into using SPSS. Remember that there are two main views in SPSS, and we can toggle between those two views using the tabs at the bottom left-hand corner of the screen. One of them is called variable view. So if we go to variable view, and right now I'm looking at the data from our class survey, which I've actually now uploaded to our website. So you can also open this file in SPSS if you would like and follow along. It's called 212survey s21.sav. Remember that .sav is the file extension for SPSS files. So just like .pdf or .doc, it's something that we're going to see again and again when we're using SPSS. Under variable view, we have a list of all of the variables that we collected data for, or in this case, all of the questions that were on the survey that you all answered a few weeks ago. The first thing we do for each variable is we give each variable a short but descriptive name. And remember that we can't include spaces in the name of a variable. This is often easy to do with things like age and gender, but with other variables like how many days a week do you exercise, we may not be able to capture everything we want to know about the variable just in its name. So for a variable like that, we can also add a label, which is a more thorough description of what exactly that variable is measuring. So for the exercise variable, for example, we called it exercise, and under label we can clarify that people's answers to this question tell us how many days a week they exercise. You can think of this as being kind of like our operational definition, where we explain how exactly we're measuring the thing that we wanted to measure. Next, under the column that's called measure, we can indicate what kind of variable this is, either nominal or ordinal, or a continuous variable, which SPSS calls scale. If we're working with categorical variables, we also have one more step, which is to give a number to each category. So for example, under gender, it looks like 1 is being used to designate female, 2 is being used to designate male, I assume, but we can find that out for sure by clicking right here. And SPSS will give us a list of each category along with the number that corresponds to each category. So that's variable view. If we go to data view, this is where we actually see the data itself. So we see people's answers to the questions that I asked on this survey. First thing we want to do in data view is in the view menu at the top, we want to make sure that the box next to value labels is checked. What that will do is for all of our categorical variables like gender, class year, and so on, it will replace the number with the label. So it actually tells us what category people are in, so we don't have to remember which number corresponds to which category. Remember that in data view, each column corresponds to a variable, and the name of that variable appears at the top of the column. So siblings, for example, is a scale variable or continuous variable that tells us how many siblings each of you has. Each row in data view represents one person. In other words, all of your answers appear in the same row. I don't know who's who, obviously, but if I choose a person, say person number 9, we know a lot about this person. They're 19 years old, they're right-handed, they're female, they're a junior, they live off campus, they're 65 inches tall, they have one sibling, they have hazel eyes, they live 35 miles from their parents, and so on. So in any given row is all of the answers from one individual person. One other thing to notice, sometimes people might fail to answer one or more questions, and as researchers there's nothing we can do about that. Person number 13, for example, as you can see on the screen, they didn't answer the question about height. So we're never going to know how tall that person is. What we're going to do is we're just going to leave that space blank as a recognition that they didn't answer that question, so that we don't know how tall they are. We also talked briefly last week about how we can use SPSS to get frequency tables and frequency graphs by going to Analyze, Descriptive Statistics, and selecting Frequencies. When we do that, we get a pop-up window that looks like this. On the left-hand side is a list of every variable that we have. If we want to create a frequency table and or a frequency graph, we're going to find the variable that we're interested in, and we're going to highlight it, click the arrow button in the middle to move it over to the variables box. If we also want a graph in addition to a table, we can click the charts button, and depending on what kind of variable it is, we can request the appropriate kind of graph. So a histogram for a continuous variable or a bar chart for a categorical variable. I went ahead and did this for one of the variables that was included in your survey, which was height. Here is what the frequency table for height looks like. So it looks like we have 12 people who are 64 inches tall. We have 10 people who are 66 inches tall. And for any of these heights, we can also say not only how many people are that many inches tall, but we can also say what percent of people are that many inches tall. Notice SPSS also tells us something called missing. Missing just means how many people didn't answer that question. So if we look at the bottom of the table, we know that there are 75 total people in the class, but there are 6 people missing. In other words, only 69 out of those 75 people answered the question about height. There are 6 people whose heights we don't know. For that reason, when we're calculating a percentage, if we ever wanted to do that, we would use the column that says valid percent. What that tells us is the percentage of people who answered this question who are of that particular height. So for example, 17.4% of the people in the class are 64 inches tall. 17.4% of the people who answered this question, I should say, are 64 inches tall. We can also look at a histogram of height. As someone pointed out during class today, these bars really should be touching each other, even though they're not, because when we graph a continuous variable, the bars should be touching. What we're going to talk about today in more detail is distributions. Remember that in statistics, when we use the word distribution, what we're talking about is the overall shape of the histogram. So if you kind of imagine drawing a line that roughly connects the tops of all of the bars on the histogram, that's what we mean when we say distribution. So this particular distribution, there's a lot of tall bars between, say, 61 and 66 inches tall, indicating that most people in our class are somewhere between 5'1" and 5'6". However, we also have a smaller number of people that are much taller than that, as evidenced by these tiny bars that are much further to the right on our graph. So we have at least a couple people that are 75, 76 inches tall that cause our distribution to be a little bit lopsided, which again is something that we'll talk about more in today's video.